Well, I'm a mathematician, and as my title says, Why Maths? A Mathematician's Story. Well, the first bit, why maths, is really easy, because I really love maths. Maths is a huge amount of fun. Okay, having got that over and done with, let's continue on. There are actually many, many other reasons to do maths. My reason was because I really enjoyed maths. I love solving problems. I love getting things right. I love understanding maths. Maths tells you so much. But as you can see here on the slide, there are many, many other reasons to do maths. This is just a collection of job ads that someone put together. I just grabbed them off my pile a couple of days ago and typed them in. You might not think that biostatistician, modeler, games developer, analysts, market risk analysis, things like that are jobs for people with maths. But all of these jobs were advertised and maths graduates were invited to apply. And this is just some of the things available. This was just one little thing I picked up a few days ago. There are so many things for maths people to do. A lot of my friends work in banks, some work in universities, and they work in all sorts of large companies in many places. So that's another reason to do maths, but it's not the reason I'm doing maths. As I said, I love maths. And in that list, what I'm doing is not there. I'm a university lecturer. But I'd like to start a little earlier, when I was at high school. I went to Turramurra High School, which is not far from where I am in this studio here, though I'm nowhere near there now. I work in the University of Western Sydney out at Penrith. At high school, I loved maths and science. I enjoyed the subject. Science tells you so much about the world. Maths is a lot of fun, and with maths, it helps you understand science as well as other things. One of the other subjects I also studied was French, only till the end of year 10, but I enjoyed French as well, and I've put that there because a reference to that will pop up again later. In the end of high school, for my HSC, I studied Maths Extension 2, though when I did it, it was called 4-unit maths, but it's Maths Extension 2, which was the most maths I could do. I studied physics and chemistry. They were lots of fun. And then I had to do some other subjects, had to do English, and I also chose economics. Now, I didn't really want to do English. I didn't really enjoy English. I didn't really work at it, and that was a big mistake. I think you should work at everything you've got the opportunity to learn, and I wish I'd worked hard at English because despite the fact that I'm a mathematician, I do a lot of maths, I teach a lot of maths, English is really useful because I need to know how to write. Many, many people do. I thought when I was at school that writing essays on Shakespeare, why would I do that? I'm not going to have to write essays on Shakespeare in my life. Well, I don't. But I do have to write other things. And if I'd learnt my writing skills and writing essays on Shakespeare and Jane Austen and other things, I'd have been a better writer, and I'd probably be a better writer now. And some things in my life would have been easier. However, I've survived. I got through the HSC, and I'll mention one thing I had the chance to do while I was at school, which was really good. At the end of year 11, I got to do something really, really good in my summer holidays. I got to spend 2 weeks of my holidays doing maths. Doesn't that sound good? Well, it was great. It's called the National Maths Summer School. It's run for students at the end of year 11 and takes some at the end of year 12. I met 70 other school students who loved maths like I did, and we had a fantastic time. Now, these days there are many opportunities for things like that. The National Maths Summer School still runs. There's a Science Summer School. There are many opportunities for things outside school in all sorts of areas. And I'd encourage you to look for these and have a go for them if you get the chance. And another thing I did during school was I helped some of my friends with maths because I liked maths. Some of our friends needed help, and that was fun. And you know what? In turn, some of them helped me with some of my other subjects. It all worked out really well. After school, actually before I started university, I got a chance to spend another 2 weeks of my holidays at the National Maths Summer School. And then I started at the University of Sydney. I enrolled in a Bachelor of Science because that way I could do some science and concentrate on maths. Well, University was really different to school. In university, we didn't have, just one small classroom with a teacher who knew us well. It wasn't like that at all. In my first year maths subjects, I was in a room, this huge room with about 300 other people, and the lecturer down the front. The lecturer was good, but there's no way the lecturer knew me, and I don't know that I ever talked to the lecturer in first year. It was very different. And then we'd break up into small groups called tutorials, and we'd do problems and talk to people and practice what we'd learnt. Now, that's very different to school, especially as nobody knows whether you're attending the lecture or the tutorials or not at university. There's a lot more responsibility on you. You have to take control of your learning, and if you don't want to learn, you don't want to learn, but then you probably fail. Now, when I went to university, there was nobody from my school, maybe one person from my school, doing similar things to what I did. But I was lucky because I'd been to the National Maths Summer School. I was used to lectures and tutorials, so I was used to the style of learning at university. And I also had quite a few friends from there who were doing the same thing as I was at university. And that was great, going to this new place with a new structure, but with people I already knew. Now, with my Bachelor of Science, it takes 3 years to do a Bachelor of Science if you do it full time. In my first year, I had to choose 4 subjects. So I chose maths, physics, chemistry and biology. And that was fun. The physics, chemistry and biology, we had labs, we did all sorts of things. Maths was great, we learnt lots of maths, moving on from where we were at school. In second year, I just did pure maths, applied maths and physics. So notice I did mostly maths. And in third year, I was able to do all maths, which was exactly what I wanted. And there's one more note I've got in my slide that I earned some money while I was at university, and these days most of the students at university do a bit of part-time work and earn some money. And for me, I used my experience helping people with maths and did some work tutoring high school students with maths, and that was a good way to earn money. The money was better than stacking supermarket shelves or things like that, which is what some of my other friends did. But university was fun. You get to learn all the things you wanted to do, and some of the subjects I liked less at school, I didn't have to do at university. So university was great because I got to concentrate on the sciences and the maths, which is what I wanted. Now, a few other things happened during my time at university. One was that Rubik's Cube came to Australia. That was in around about 1980. And for me, that was a good thing because I got my first cube and I don't think I put it down for a day. I've worked out how to solve it. I just love the cube. It's the best puzzle ever, in my opinion. It's just a fantastic puzzle. It's really quite difficult for most people, but most people can get a fair way with it if you're persistent. And maybe for another day, but I can tell you how to find solutions to puzzles like Rubik's Cube. But I found my own solution and I played with it a lot. And for a while, I was never seen without my Rubik's Cube. I really enjoyed it. Other things I did during my university time was I worked during the summer holidays. At university, you have a much longer summer break than you do when you're at school. Now, you can sit at home and get bored, but why would you do that? These days, most universities run subjects during summer, so you can catch up if you failed a subject at university, or maybe get ahead a little bit during summer. So you can study during summer as well. I didn't have that opportunity. I got a job. I worked full time in the break at the end of second year and the break at the end of third year. And I was very lucky. I got a job, computer programming. And that was a great thing to do because computer programming is a lot of fun. It uses some sort of mathematical thinking, very useful skill to have, and it's been really useful to me in the years since then. And I also worked with a bunch of really interesting people, some people doing research in biology, in fisheries. They were just a group, a science unit researching in fisheries in New South Wales. And that was a lot of fun. I got to earn money, learn computer programming, and see what some people did in the workforce. Now, another thing that is reasonably obvious, I guess, I spent 3 years at university, met a lot of people and made a lot of friends. Now that's been a huge advantage. I met people who are interested in the sciences, in maths, in engineering, in computer science, areas that are broadly my interests. And a lot of them have stayed friends with me over the years, and they're really valuable connections. If I want to know the opinion of a senior engineer about something, I ring up my old friend from uni and ask him. If I want to know what's happening in CSIRO, I ring up my friend in CSIRO. So I made friends that have become valuable connections, built a network, and they're still good friends. Now, I really liked my maths and I wanted to continue my maths. I could have graduated just with a Bachelor of Science, but I chose to do another year called an honours year. Lots of people graduate with a Bachelor of Science or a Bachelor of something, but not many get an honours degree. If you really like something, it's worth considering a little bit of further study, as it puts you just a little ahead of the pack. So I did another year of maths study where I studied some maths subjects and did a project that was my project with a particular supervisor. So that was 1 year, and then after that I decided to stay at uni for yet another year and do a Master of Science, so I'd have a master's degree. And that again consisted of various maths subjects, which I really enjoyed, and a thesis, which is a large work that I had to write on a problem that I chose together with a member of the maths staff, with a mathematician. So I had to write. And this is where I wished at school I'd paid more attention in English and picked up my writing skills. But I had to learn to write, and I produced something that turned out to be, it was written reasonably well, people told me afterwards. And also during that time, my honours year, my masters, I continued earning money by teaching maths. This time at the university, I got some part-time work teaching maths at university, taking tutorials. And that was great because I got to work with students a few years behind me and teach them some of the maths and have fun with them. And something that happened on the way round about that time when I did my masters. My Rubik's Cube, my playing around with Rubik's Cube paid off. Firstly, I wrote a book with a colleague, a mathematician I'd met at the university who was also very interested in Rubik's Cube. It's a very mathematical puzzle. Maths tells you a lot about this cube, what can be done, what can't be done, how to do it. And the two of us got together and wrote this book. And this book did rather well. It made it to the Times bestseller list. And that was good because I earned some money from it. And then later on, we wrote another book. There was another puzzle. Rubik's puzzle came out, Rubik's Clock, which isn't nearly as well known as Rubik's Cube, and we wrote a book on that, and that sold as well. That was a great experience. Me, who didn't know how to write really well and didn't bother at school, was working with someone else to write 2 books. Though I must admit it was my co-author who did a lot of the actual writing. I did a lot of the puzzle stuff, but he taught me a lot about writing. Something else I did around that time, I got some consultancy work, looking at people flow through a tourist attraction. Now this was really important because the number of people you can get through something depends on how much money you can get. If each person pays, I don't know how much, say $20, and you know how many people you can get through an hour, the maximum number of people, that tells you your maximum income. So it's really important to look at how many people you can get through something and how to control the flow of people. How wide doorways are depends on how many people can go through, how long it takes to fill a room. And they needed someone who could deal with some maths, who had some basic quantitative skills to look at this, because the people in the company doing this, putting together this tourist attraction, didn't have the skills. And then they got some other people in who it turns out didn't have the skills. And then they got me because I had some maths training, and it turned out because of my maths, I could do what they wanted. I solved their problems. And not only that, once we'd worked out how the people would flow and done all the calculations, because I had teaching experience, they kept me on for quite a while to train their staff. So I got quite a lot of work doing that. My maths skills were paying off. My maths skills had paid off with teaching, consultancy work, and writing a book on a mathematical puzzle. I also, after my masters, took a year off. I spent 6 months living in America, and I could afford to do that because I'd earned some money, I'd saved up some money, and largely because of the money I'd got from the Rubik's Cube book. So 6 months in America, I went with my boyfriend at the time, who'd got 6 months work at an American university, had a great time there, saw parts of America. After that, we spent a month in England and France, went to a maths conference, as you do, because maths conferences are great. Met lots of other mathematicians, lots of people from all over the world. And then I came back to Australia, and I decided that I really liked maths and I wanted to continue working into maths. I wanted to get a job at a university as a lecturer. Now, to do that, you need to know not just a fair bit of maths, but you need research training, because the job as a university lecturer is partly teaching, but also partly research. Now, for research training, typically you do a PhD. So I decided I'd enroll in a PhD. In a PhD, you take a problem that nobody's done before. It's something completely new, and you have to work on it and make progress with it and then write it up. So it's training in real research. You take something, you do research, you do something new, you do something exciting, something nobody's done before. And so I decided that's what I wanted to do. So I enrolled at the University of Sydney again to do a PhD. And I worked for 3 years on a problem. The problem was more broadly in the area of algebra. It's in an area called group theory, and group theory is what tells you about Rubik's Cube. It tells you how to solve puzzles like Rubik's Cube, including other funny looking puzzles that you might not be able to see there because that's a bit small. And there's another puzzle, it's in the shape of a dodecahedron, and it's also a puzzle, the sort of thing that maths tells you how to solve. Anyway, that was broadly the area in which I did my PhD, and I spent quite some time working with what I call bunches of balloons. Now, you all know what a bunch of balloons is, except my balloons weren't concrete ones that you could blow up and hold. They lived in much higher dimensions than 3 dimensions. And I can't show you them because we live in 3 dimensions. But I worked on these things because they helped us in the study of groups, the things that tell you about how to solve Rubik's Cube. Groups measure symmetry. They tell you about things about wallpaper patterns. They tell you things about chemistry. They tell physicists where to look for new particles. They're of use in many areas of science and beyond. Anyway, while I did my PhD, I survived by having a scholarship and also by doing some tutoring. This time I was lecturing to students. I had a group of my own students, about 30 to 60 students, and I taught them various maths subjects, which was a lot of fun, including number theory. Now, number theory is a lovely area of mathematics, and it's particularly useful for electronic commerce, online banking, things like that. Without number theory and without the mathematics behind that, we couldn't have secure communication. We wouldn't log on to the bank and do things which maybe you or your parents do. You type in your password and nobody can get it. And to do that is actually really clever. And there's a lot of maths behind that. Anyway, I did my PhD. I finished that and there it is. Yes. I went to look for a job. Well, I applied for lots of jobs, and unlike many people these days, I only applied for jobs in New South Wales because I had a boyfriend in Sydney and wanted to stay around the area. Many people apply for jobs all over the world. Some friends of mine have worked in America, in various parts of Europe, in Iceland, in parts of Asia, but I decided I wanted to stay in Australia. I sort of wish I had studied overseas. It would be a great opportunity, but at the time I wanted to stay in Australia. And I got offered one job in Wagga and one job in Canberra, and I decided to take the job in Canberra. So I worked at the Australian National University for a year doing research and teaching. And then that was only a 1-year job, so I kept applying for jobs, and I got a job at the University of Western Sydney as a lecturer. And that's what I am now. Though my title is Associate Professor, because you start out as lecturer and you move up the ranks. So I work at the University of Western Sydney. I do research, I teach students, and I do lots of other bits and pieces as well. But before I tell you about the sort of things I do in my job as a mathematician at a university, The things that were important to become a university lecturer in maths, in the sciences and more broadly, are the 4 I've listed on my slide there. You need a bachelor's degree in a relevant area. You need good knowledge of the area, like for me, mathematics. If it's, say, chemistry, you'll need a good knowledge of chemistry. If it's engineering, you'll need a good knowledge of engineering. You then need a PhD in the area. That's research training, because the job is research, so you need to be trained in research, and that's what a PhD does. You need to be able to communicate. You need to talk to students, and I hope that I communicate well with my students. I try. If you ever meet some, ask if they think I'm a good communicator or not. But I try as hard to communicate with them orally and in writing when I prepare materials for them. When I do research, I don't just do it and have a warm, happy glow thinking, hey, that was fun, I've learnt something new. I also have to write it down and communicate it. Other people, other experts, mathematicians look at what I write, and if it's good enough, it gets published. So there's an example of a book of papers which includes a paper that I've written with some colleagues, and we have to do that and write things up, get them published. That's part of working at a university as a lecturer. And another thing is, you've got to show, to get a job doing research, you've got to do research to show that you can do research. After all, if somebody's going to employ you to do something, they want to know that you can do it. So I'm a lecturer at the University of Western Sydney, and I'd like to just tell you the sorts of things I do. A typical day might include giving a 2-hour lecture to 150 first-year students. Large room, a lot of students. Unfortunately, I don't get to know them all. They don't all get to talk to me, but they do also have smaller tutorials where they get to know their tutor, who might be me or might be somewhere else, and they work on problems. Sometimes I work with students one-on-one. For example, last week I had a 1-hour meeting with a project student. And this student, he's got his own project, his 3rd year, he's quite a good student, and he's going to read some stuff, learn some stuff, do some problems and write it up. I might be writing a paper for a journal or a conference, so I might be have done some research, but then I have to write it up. And I'll often be working with 1 or 2 others doing this. So I'll communicate with other people, and we'll write something up, make sure it's written really well, make sure it's all correct, and then send it off to be reviewed and hopefully approved for publication. I also want to keep up to date. I want to know what other people are doing. One way of doing that is to read what other people have written. I might take this book of papers which contains something of mine and read other things in there to find out what other people are doing, so I know what's going on. I've got to find out what's happening in the world, in my area, in mathematics. I'll communicate with students and other staff, often by email. I'll talk to other people, administration. There's always forms to be filled in, spreadsheets of marks to be filled in and sent off, and so on. Now, one thing I just want to point out, for an undergraduate, if you go to university in the next few years, you'll find you have lectures for about 26 weeks a year. It's only half the year. You will have stuff to do at other time. After the end of lectures, there's usually a week's break and then several weeks of exams. And then there's a break between semester. And as I mentioned, there's a long break over summer. But I'd just like to point out, as a university lecturer, I don't get the same holidays as students. I don't get time off over summer. I only get 4 weeks leave, like most people in most jobs. But if you're going to continue on and do research students, like people doing a PhD, they also only get 4 weeks off a year. A lot of what I do as a lecturer, a few other things I might do is come out here and give a talk to people. I visit schools occasionally, meet school students, meet teachers. It's something I enjoy doing. I might attend a research seminar. That's another way of finding out what other people are doing. You get to sit and hear what fascinating things other people have done, what things they've done with topology, with algebra and different dimensions, and so on. One way I attend research seminars is to go to conferences. For example, last year I was at a conference in France. It was at a beautiful place called Rouen, and afterwards I got to spend a weekend in Paris. And learning French at school has paid off various times, because I've actually had various visits to France, and it's just nice being able to speak a little bit of the language, get around a bit with the French I learned at school. And that was fun, you know, using what I learned at school. But I must admit, learning French at school has been useful for more than just getting around France when I'm on conferences. It's helped me to learn a little bit about other languages and helped me to understand more about English. which in turn helps me to write better and to help my students write. Recently, I went to Brisbane, visited a colleague there, found out what work they were doing. My colleague in Brisbane is doing some fantastic stuff. She has a lab, a large lab with a lot of robots and students, and they're working on robotics, working on robot navigation, robot communication, and that was fascinating to see. Last week I spent a few days in Newcastle talking with colleagues. I gave a presentation there, heard what they were doing. So I get to go around a bit and really make an effort to hear what other people are doing. I also talked to some of my colleagues in Melbourne. I'm working on something a little different to what I've mentioned so far. We look at how students cope with first year mathematics once they come to university, which is a big issue. We want students to come to university into maths and succeed. And we look at strategies for success, what problems are, and so on. And when I work with my colleagues there, often we just get on the phone and talk. Whereas I have some colleagues in Belgium, and because of the time difference, we usually just email each other. They're working on some fascinating maths, which tells you about nanotubes, carbon chemistry, buckyballs. Mathematics tells you some of what's possible and what's not possible in carbon chemistry. It's really quite amazing. The National Maths Summer School I mentioned, that's still running, and I'm now Deputy Director, and I spend some time organising that. I do other things like mark students' work, plan courses and teaching for the future. Sometimes I'm on an external committee, for an example, looking at the new national curriculum because we're interested in that because it affects what students coming to university will know. And that's a bit about me. That gives you maybe some idea of what me as a mathematician does at university. But I'd like to finish off by telling you a little bit about a few other people. Firstly, the big news, and you might have heard it on the radio, you might have heard it on television. A woman, Mariam Mirzakhani, and I've probably pronounced the name badly, is the first woman to win the Fields Medal. That is huge news. The Fields Medal is like the Nobel Prize in maths. There isn't a Nobel Prize in maths, there's the Fields Medal. It's the biggest honour in maths, and not many people have won it. I think about 56 people ever. And for the first time ever, a woman has won it. It was announced last week. And it swept the mathematical world, and it made it onto the radio as well. Marianne has won a Fields Medal, and as she says, she'll probably be the first of many women to win the Fields Medal. And there's a quote there from her. She was quoted in a news article about maths. This is what she said. It's fun. It is fun. It's like solving a puzzle or connecting the dots in a detective case. And I agree completely with her. Solving a puzzle like Rubik's Cube is doing maths. It requires mathematical thinking. The area that Mariam works in is highly complex. She did some really amazing stuff with complex geometry. And she also says it's like fun. It's like solving a puzzle. And the picture there was just taken by someone last week. It's not a great photo, but it shows you two colleagues who I have a lot of respect for, Professor Jenny Seabury and Professor Mirka Miller. They're mathematicians. Jenny Seabury has done a lot of work in what's called combinatorics. It's an area that I also work in at the moment. That includes a lot of coding theory, which, for example, tells you how to send messages electronically. It tells you about, for example, how the Mars rover communicated with Earth. You don't just send a message and hope you get it. You've got to be very clever so that noise or dropouts don't affect what you receive. And Jenny works in that and cryptography and has received a lot of honours for her work in that area. Mirka Miller is professor working at the University of Newcastle. She has a lot of people from all over the world who want to come and work with her and study in something called graph theory. And graph theory is the area of maths that tells you about nanotubes, carbon chemistry, and what's possible. Now, that's probably all I want to say. I've told you a little bit about what I do and a tiny bit about other people. And I think we have some time for questions. If anybody's got any questions, I'm happy to answer them. Yes, I will continue teaching. My job is part teaching research, and I intend to continue that for the foreseeable future. I enjoy the teaching. I enjoy working with the students. I enjoy the research in maths. So I will continue. I intend to continue all those things Yes, I have no plans to move and do anything else at the moment. Oh, that's an interesting one. It's probably Rubik's Cube. Even though this puzzle I'm holding up, this 12-sided thing called the dodecahedron, which has 12 pentagonal faces, is in some sense more difficult. The Rubik's Cube was the first puzzle of this sort I came across, and once I'd solved that, the mathematical techniques and thinking I used to solve that, and then some of the maths related to it that I learned, made other puzzles much easier to solve. So actually on the first slide, I'll just go back to my very first slide. Notice that absolutely huge puzzle there on the right. That's got, I think it's over 1,000 stickers, many faces. It's also a 12-sided figure, a larger dodecahedron. That would even be easier for me to solve now because of what I learned in solving Rubik's Cube. So I have to say that Rubik's Cube is the most difficult puzzle I've solved. But it doesn't mean that you can't solve it. I think everyone should have a go at Rubik's Cube.